In the example we're going to review today, we will create a 2D array that stores 4 students' grades, and we'll have 4 grades for each of one of those students. What we're looking at here is a visual representation of where the data is stored in the two-dimensional array. I like to think of 2D arrays as sort of a spreadsheet. How they're implemented in Java is a bit different, in my opinion, a little bit backwards. The row index subscripts are placed first, followed by the column subscript. Say we would like to store a grade in the first cell, index 0, 0, 0. We would assign an array named grades, and we'll write it out, grade sub 0, sub 0, and we'll say is equal to 94. We would then assign the next cell 95, and then continue on and so forth until we got to the end of that particular row and hit the upper end of the bound for the length of the first row. We can determine that by typing grades sub 0 dot length, which will give us the length of the first row at that index position 0. Determining the depth, or how many rows are in a 2D array, we can determine that by simply typing grades.length. To move on to the next row, we will type grades sub 1 sub 0, meaning we moved on to the second row, but the first element in that second row. And moving down the column as we did in the first column. Now that we know what this looks like practically, we can create a program that stores grades in a Java development environment. So first things first is we'd have to set up 2 constant variables to set the upper and outer bounds for the X and Y axis of our arrays. So here we simply put final and then we can still use students, and we'll set that equal to 4, and then we'll say final grades, and that's the number of grades per student, and that'll be equal to 4 as well. And so we'll need a variable to store the total points, being really the numerator, and then also the class average. So what exactly the average is for the class. So we'll make 2 double variables, total points, and we'll have to initialize this one, and then double class average, which we don't need to initialize, and you'll see why. What we will do is also initialize a double array, but it'll have 2 brackets, 2 sets of brackets indicating it's a 2-dimensional array, and then we'll call the array grades, and we'll set that equal to, and we're going to initialize a new array, new 2-dimensional array. The compiler already knows you're going to probably want to initialize a 2-dimensional array, and we're going to set the first. It doesn't really matter which one we use, but just for sanity's sake, the rows will be the students, so students, and then the columns will be the grades, just like in the presentation at the beginning of this lesson. So now that we have that set up, we're going to have to import our scanner class, just so we have a way of communicating with the user, and we're going to create a new method, or a new scanner object, and be the standard keyboard. And then we'll also prompt the user in the same way that we've been prompting the user this entire module. So I won't worry you guys with that part. And so what we will do though here is we'll change the second line to say enter, and we'll format this, enter the grades. So we're going to use the grades of 4 students. So we're going to use X as the way you format an integer. So 4 grades for 4 students. And we're going to put grades and students here as what's being formatted, right? And then we'll, to actually create and fill the for loop, or the 2D array, we have to create a for loop. And it'll be a nested for loop. And so just think about what we're going to do. We're going to go down each row, and then each row we're going to fill in just like we did this, like we showed in the presentation. Each row will fill in each element in each row will fill in the elements sequentially. So we'll say for an integer, we'll call the integer index variable stud. And we'll say as long as stud is less than students, and then we'll increment stud by 1 every time. And then we'll put another for loop for an integer grade. That'll be the indexing variable for this for loop. And as long as grade is less than grades, the constant variable, we'll say, and also grade plus, so increment it once. And while it's doing that, we'll say system.out, and then print format. Here we'll say student, and we'll again use the integer student 1 or what have you, grade, whatever that grade might be. And then we'll say stud plus 1, because remember it's always stud would be 0 on the first loop, so we want to say student 1. And then their grade will also be grade plus 1. And so there we want to say grades. Now we access the actual 2-dimensional array. So we'll say grades will be indexed on whatever the row might be at that time, and whatever the column might be at that time. And those are based off of the indexing variables, right, in the for loop. And it will be equal to keyboard dot next double. And so that's the nested for loop that's actually going to get us all of our grades, right? And then we're going to do system.out.println just so we can get an extra space after we're done with that for loop. Now we're going to have another for loop that will tell us, that we'll use to print out all the grades back to us. and then after that, we'll ask what the class average is. So we use a very similar for loop. We can actually reuse the indexing variables. And it's basically doing everything that we did in the first for loop again, but in reverse. And it's going to regurgitate. It's going to regurgitate everything that was inside of each element of each of the 2D array, and then it will spit it into the variable that we created up here, total points, which will just be the numerator for our average. So total points will be plus equal to grades, stud, and then grade, right? And so total points is actually the accumulator for this for loop, right? And then after this nested for loop is completed, going through every single element of the 2D array, we'll set that equal to class average, and we'll say total points will be divided by students, so the total students plus total grades, and or actually not plus, it'll be multiplying, so it'll get the area of the 2D array and multiply it to figure out how many elements of the array there are. That will then divide it by whatever the numerator the accumulator collects in the second nested for loop. And then here we'll go system.out.printf, and we'll format it again. We'll say the class average is use a flag. We want 2 levels of precision. And here we'll just reprint whatever class average is. All right, so did a lot there. So let's recap. We created created a 2-dimensional loop, a 2-dimensional array, and filled the 2D array with information. Down here, we accumulated that information to then be averaged. So we created the numerator to then be divided by the denominator, which is the area of the 2D array, and that gives us the class average for the entire class, not just the individual students, but the entire class. So let's go ahead and run this program. So here it asks student 1 grades 1. Or you say, we probably should have said grade here, but we'll correct that later. And we'll say 90. This thing got a 99, 98, 95, 92. Second student, mediocre, 75, 76, 74, 72. Student 3, we'll say 85, 84, 86, 83. And student 4 just really messed up, 65, 67, 64, and give them a 75. So it prints out the class average at the end of the program, at the end of after the program is completed. That's what this last piece of code does, and it prints out. All right, so you can have multi-dimensional arrays. You can have you have as many dimensions as you want. It gets a little bit complicated and a a little bit harder to actually visualize and conceptualize, especially since we live in a three-dimensional world. So having a four-dimensional or five-dimensional array, definitely possible, but hard to actually conceive. But there are definitely instances where you might need a four-dimensional array, not necessarily defining a physical object in 4 dimensions, but you can your book has an instance where you have a widget on a row on a 2-dimensional plane somewhere in that in a warehouse, and then you have multiple warehouses. So the multiple warehouses part could be the 4th dimension or the additional layer. If you have any comments or questions about how to implement this in Java or even in any other language, I've been thinking about this a lot with, in particular, Java. You can implement this, but some programming languages like Python are particularly designed to manipulate multiple data sets and relatively quickly in an array, and it's a bit easier to implement arrays in different programming languages, but especially Python or R, which was designed from the bottom up to manipulate large data sets. If you have any questions, let me know.